This question is about somebody who's diving. They have a known mass. They dive into the water. They're a certain height above the water. And what is energy conservation going to say? It's going to say the change in energy is going to be 0. So that means the energy final minus the energy initial is going to be 0. What does that mean? Energy final equals energy initial. The energy is not changing. It's the same up here as it is down here. It's just going to be transformed into different categories. Remember, the energy at any point is equal to all of the types of energy. Here, clearly a change in height is going to be the gravitational energy. You know he's going to be diving in, so he's going to have some kind of kinetic energy. I don't think there's no spring. Well, if this was a bouncing diving board and we were wondering about this the diving board itself, there might be some spring energy in there. But let's just imagine this is a diving tower with no flex in the board. He's just jumping off. Well, the energy is going to be the same. What's the energy up here? Energy initial is, well, the kinetic energy is 0 up here. He's not really moving. Kinetic energy is equal to 1/2 mv squared down here. Up here, especially if we call this level, if we call this 0 and this level and this height, this vertical position h, his energy in the gravitational field is mgh, and down here the energy is nothing. Gravitational energy is nothing. So that would take you from part A just to equate this to this. Whatever the energy in gravity is he has up here, he's going to lose that, and it's all going to end up as kinetic energy at the bottom. Part B and C. Part B says he starts with some kinetic energy. It says that he starts by jumping up off of the tower, and so he has some initial velocity here. So his kinetic energy is not going to equal 0. It's going to equal some kind of initial velocity. And so this energy is not going to be lost, so it's going to be taken down, and the gravitational energy is still going to be 0 down here, so all of that is going to funnel into the kinetic energy down there, so he's going to end up having more kinetic energy down there than he did before, because he's going to have all of his initial kinetic energy plus how much gravitational potential energy was lost. So by jumping up here, he's going to hit the water even faster. He does something wacky, maybe monkey trick somehow, climb underneath here and launch himself downwards with the same initial velocity. Energy doesn't care which direction you're going. This kinetic energy, the velocity is squared, plus, minus, at an angle, it doesn't matter. So he is going to have, again, an initial kinetic energy. It's going to, he's moving downwards, but kinetic energy does not carry direction information with it. These are not vectors. They're just scalars. They're just an amount. So which direction he's going doesn't matter at all. In fact, he could jump horizontally too with this initial velocity. And all that means is that the energy doesn't tell you which direction he's hitting, but we do know that when he ends up hitting the ground, he's going to be going faster than if he had just jumped, just dropped off. And so part B and C, you're going to expect to have the same final speed.